If you ask AI to build you a full stack application, or if you watch a 10-hour full stack app tutorial, you'll probably see that the backend logic centralized in a single service using a single database. But this approach might not be the best solution, especially for building real-world large-scale applications. So instead of blocking your data flow with a bunch of awaits and making users wait 12 seconds for a response, you can actually break your application into small pieces. And at the end, all services are independent and easier to work with as a team. And to run these services in parallel, you can use one of the most popular open source event streaming platforms, which is used by the biggest companies. In this tutorial, you will learn Kafka, how to use it, and how to integrate it into a real application. If you are ready, let's get started. Okay, I created two simple applications. One of them is the front-end application that will show our design. Let's assume that we have some products and the user card is already saved. And when I click this checkout button, it will make a request to our backend server. Here we have the backend. It's a really simple application. We have just one endpoint. We'll get the card details from the user. And here we have a dummy middleware that we can reach the user ID. When a user clicks the checkout button, first we'll wait for the payment process. If it's successful, we are gonna log this information and send it to the analytic database. After, we'll create an order using the card details and the user ID. And if this is successful, again, we are gonna log the information. After that, we'll send a confirmation email to the user. And finally, again, we'll log this information. But the problem is all these operations take time. To create the order, we have to wait for the payment result. To send the email, we have to wait for the order. And each time we are logging some data. And only after all this process completed, we are sending the response. And depends on your infrastructure and the user traffic, it might take really long. Let's say all these operations take 3 seconds and the logging operations take 1 second. That means the customer has to wait for more than 12 seconds. Of course, all these implementations are dummy for the test purpose. We are not using any database, or for the logging, we are not using any library like Pinot. But anyway, we have to wait for each promises to be resolved. And the worst case is, if one of them fails, it's gonna send an error. I'm not using try catch here because after express.js version 5, it automatically catches the promise errors and sends them to the error handler here. So even if payment is successful, order is created, if there is something wrong with the email sending, it's gonna return an error. Let's try. I'll click. It will wait for all the payment and the database process. And it takes 12 seconds. And if there is something wrong with the email, let's reject here. New error. Email failed. I will come back, click again. Again, we'll wait, but at the end, we'll see this error. When the customer sees that, they will probably try again and again and pay for the same order over and over again. So this is why using microservices can be the better option. Let me explain. So instead of sending a request, waiting for all these operations and sending the response, we'll create small and independent services. For our example, we have 4 main services. Let me change the colors. This is gonna be the payment service, the order service, email, and analytic. And they all have their own independent functions. For example, for the payment service, we'll have the pay function. For the order, we'll have create order, delete order, or whatever it might be. For this service, we'll implement the email sending. And for this one, it's gonna be, let's say, log data. Right now, for each service, we can use different libraries or databases or even different languages. For instance, for the payment service, we'll be connected to Stripe to receive the payments. For the order service, we can use a database and manage the orders. For sending emails, we can use tools like SendGrid or Mailgun. And for the logging, we can use any analytic tools. And right now, our application is much clearer and it's easier to work with. Especially if you have a team, each group can work independently and focus on just one thing. But how these services will communicate with each other? There are different solutions like RabbitMQ, Kafka, or Redis. But for this tutorial, we'll be using the most popular solution, which is used by the biggest companies. And this is gonna be Kafka. I'm gonna explain how it works in details, but for now, let me explain briefly. Firstly, we are gonna connect to the Kafka server with all our services, and it's gonna allow real-time communication between them. Using Kafka server, we'll create different topics, and using our microservices, we are gonna produce or consume messages in specific topics. What I mean by that? When a user clicks the checkout button, we'll make a request to the payment service, and if the payment is successful, we'll send the response to the user immediately and send a message to payment successful topic. And we can subscribe to this topic anywhere we want and get this data. In our example, after the successful payment, remember, we are logging the data and creating a new order. So we can subscribe to this topic on the analytic and the order services. The order service is gonna create the order, and the analytics service is gonna log the data. So they are not gonna block each other anymore. They will work at the same time. They are independent. After creating order, again, we'll send a message, but this time it will be order successful. We can send the order ID and the user ID. And we can subscribe to this topic and receive the messages in the logger service. And again, it's gonna log the data. And remember, this communication is real time. Sending and receiving messages take just milliseconds. And also, we'll subscribe to it in the email service and send the email. These two operations are happening at the same time. And finally, after sending the email, we can send a message to email successful topic, send the data, and receive that in the logger again, and save the data. Right now, the user receives the response after 3 seconds without waiting for the other services, and the services are working independently and much faster. And the best thing is, if one of our services is down, Kafka is gonna send the message when it's online again. So we are not gonna lose any data. But what if the Kafka server is down? I'm gonna explain how to prevent that and how Kafka actually works. But before, let's create our services and write some code. Okay, let's create a new folder here. and I will say services. And inside, I'm going to create my microservices. The first one will be payment service, order service, email service, and analytics service. I'll also create my Kafka service, let's say Kafka, and finally our frontend, let's say client. Inside this client folder, I'm gonna paste my React application. It's gonna be exactly the same application. We are not gonna change anything except for this API endpoint. Right now we are going to be using our payment service and we are going to send the card details. Okay, let's close here and this client. And since our services are independent, we can use different languages for different services, but for this tutorial we'll be using Node.js. Let's initialize our Node.js application. I'm going to open my terminal, open the payment service folder, and I'll say npm init-y, and I want to use import export, so I'm going to change the type and it's going to be module. Okay, let's create the index file, and to connect to Kafka server we are going to need the Kafkajs library, so I'll say npm install Kafkajs. Okay, so let's do the same thing for the other services. Actually, I can directly copy and paste them. And I'm just going to change the name here. And the last one. Okay, let's close everything here. And for the payment service, I'll be using express.js because we'll make a request from the client. So let's install Express, the latest version, and also course. I'll create my application quickly. Import Express from Express. I'll create my app and listen to port number 8000. And when we are connected, let's say payment service is running on port 8000. I'll write my middlewares here quickly. App.use will be using course. So only our front-end application can make a request. Remember, it runs on this port number here. And I will also use express.json because remember, we are sending the card details here. Let's import course. And finally, the error handler. Error request response and next. If there is any error in the API endpoints, we are gonna catch that. Okay, let's create our endpoint app.postRequest. Remember, our endpoint is payment service. We'll get the request, return a response. Of course, we'll get the card details from the client, request.body. And you can implement an authentication middleware here to get the user ID, but this is just a test. So let's assume that we get the user cookie and decrypt the user ID. For now, I'll just say 1, 2, 3. And here you can implement the payment process. You can use Stripe or whatever you like. Let's skip here also. So I'll say to do payment. And here we'll send a message to payment success topic using Kafka. And finally, we'll return the response. Let's say payment successful. Let's see first whether it works or not. I will just say API endpoint hit. I will open my console, run my application, node index.js. Okay, service is running. Let's also run our front-end application. npm run dev. I will click and it works. Okay, our backend server is working. Right now we can set up a Kafka server, but before, let me explain the structure of Kafka. Let's create a Kafka server. This server is also known as broker. And inside a broker, you can create as many topics as you want. In our example, these topics will be payment successful, order successful, and email successful. After running your Kafka instance, you can connect to this instance with your application as a producer, consumer, or both of them. Basically, a producer writes a message to a specific topic, and a consumer reads the messages from that topic instantly. In our case, the payment service will be the producer of the payment successful topic. The order and the analytic services are gonna listen to this topic as consumers, and if there is a new message, they are gonna run their functions. It's gonna create a new order, and it's gonna log the data. After creating the order, it's gonna use its Kafka producer and send a message to this topic. And again, we'll consume that message in the logging service and log the data. We'll also consume this topic in the email service and send the email. After sending the email, it's gonna run the producer. Producer is gonna send the message. And again, we are gonna consume this message here and log the data. This is the basic structure of Kafka. But there is a problem here. If you create only one instance for each topic, over time, a single topic is gonna store thousands of messages, because Kafka is not deleting the messages as soon as they are consumed. And if you want to use a specific order or group for your messages, it's not gonna be possible with only one instance. So what we should do is, we should create multiple partitions for each topic. Let's say topic A and partition 0. One and 2. You can create as many as you want. So right now, when a producer writes a message, it's gonna write it into one of these partitions. Let's say partition 0. When you create another message, Kafka will randomly select a partition and send the message to that partition. But if you want messages to be evenly distributed, you can implement a strategy called round robin. So when you create another message, it's gonna write it to the second one. And the next one will be written on the next partition. So each message is gonna follow this path. The first one will be here, second data, and third. When we add one more message again, the other one will be here, and the next one will be here. And as soon as there is a message on one of these partitions, we'll read them in the consumer. And the order will be exactly the same. But also you can group your partitions and create a different rule. Let's say you have 3 consumers and you want to consume the data according to first letter of the username, like A to I here, J to R here, and S to Z here. And you can read the data only from the first partition here, second partition here, and the third one here. So you can store your messages in the different partitions, and also you can consume them from different partitions. Producing and consuming messages in Kafka are so flexible. Depending on your project, you can follow different strategies. So let's implement this single Kafka server to our project, and after that we'll go ahead and create a Kafka cluster to provide fault-tolerant systems. Okay, to create a Kafka server, the easiest way is using Docker. So we are gonna run our local Kafka server and connect to that server using our services. If you haven't used Docker before, or if you think it's hard to work with, don't worry, I promise you it's really easy. Just go to docker.com and download Docker for your desktop. After doing that, open your Docker application. Let me zoom in and create an account. And now you are ready to install Kafka container. Let's create a Docker Compose file in the Kafka service. I'll say services. And the first service will be the Kafka itself. I'll say image. And right here, the official Kafka image. If you visit hub.docker.com and search for Kafka, as you can see, this is the official image, so we can trust this image. And as you can see, it's been downloaded more than 100 million times. This is how popular it is. Let's use it. It's gonna run on this port number. And also I want to install one more service, and it's gonna be Kafka UI. So we can see all the brokers, all the topics, partitions, and we can create new topics. We don't actually need a UI. We can do everything on the terminal, but it's gonna be much easier for you to understand because everything will be visible on the browser. So I'll say image. By the way, let's give a space here. For a Kafka UI, there are many options, but we are gonna be using the most popular one. You can also give a container name, Kafka UI. We can do the same thing here. And I'm gonna write the port numbers. Let's give a space here. It's gonna be under Kafka. And here. And it's gonna run on this port number. You can give any port number you want. And I'll say depends on the Kafka container. So it's gonna run only if there is a Kafka server. So this is gonna be our Kafka network. Let's write it here. Networks, and let's say Kafka network. I will do the same thing here. You can give any name you want. And we are gonna define our network here. At the very beginning, I'll say networks, the network name, and the driver will be bridge. Okay, and now we are gonna add some environment variables to configure our server. For now, I'm just gonna copy and paste them, but don't worry, I'm gonna explain everything. And as always, you can find all the code in the GitHub repository. You can find the link in the description below. Let me close this menu. And why I copy and paste is because for now, you don't know how to work with multiple Kafka servers and how to connect them with the controller. But as I said, I'm gonna explain every single line here after you learn how to use producers and consumers. Just copy this compose file from my GitHub repository, open your terminal. Let's create a new one. I'll open my Kafka directory. Of course, it's inside the services. And I'm gonna run docker compose up. When you install these images for the first time, it's gonna take a while because it's gonna download them. And after everything is done, you are gonna see this message, Kafka server started. If you check your Docker container, you are gonna see that our containers are here. Let's check. As you can see, Kafka server started. UI is also working. Let's visit here. And this is our current status. Our cluster is online. Inside the cluster, we have only one broker. We can see it here. It's running. And we can see the topics here and the consumers. We don't have any topic yet. Let's create. Remember, we have 3 topics. The first one is payment successful. In this example, we have only one partition and one broker. Later, we are going to add more partitions, but for now, for the test purpose, it can stay like that. Let's create the others. Order success. And one more, and it's going to be email. Okay, we have 3 topics. But it's not the only way to create topics. You can also use your terminal, and also you can use your application. In the Kafka directory, let me close this terminal, open my menu. Here, we have the index file. You can give any name you want, like index, admin, create topic, doesn't matter. And if you remember, we already installed the Kafkajs, so we can use it. I'm gonna close here. Open admin.js. Let's import Kafka. Kafka from Kafka. So let's create a Kafka instance. New Kafka. And inside, we are gonna write a client ID. Let's say Kafka service. You can give any name you want. And we are gonna write here our brokers. We have only one broker. And remember, it's running on 1994. And now I'll create a Kafka admin and connect to my server. Let's say const admin kafka.admin. And I'm gonna create here a connection function. Let's say run. It's gonna be an async function. And firstly, we are gonna connect to Kafka. So I will say admin.connect. And after that, we can create topics. Again, admin, create topics. I'm gonna write here my topics array. You can create multiple topics. The first topic will be payment successful. And the second one will be order successful, or you can create any other topics. And when you run your function here, it's gonna create the topics. So only thing you should do is, let me terminate this by the way. I don't wanna stop the containers. I'm gonna start again, but I don't wanna see the logs here. And you can just write node.admin.js. But since we have our topics here, it's gonna give a warning. I just wanted to show you how it works. So I can close here, and now we'll do exactly the same thing for our consumers and producers. Remember, in the payment service, we are gonna need a producer. Let's do that. I can close this and paste my code here. Let's move them right under our middlewares here. And the client ID will be payment service. Again, the broker will be the same. But this time, instead of admin, we are going to create producer. Let's create our connection function. Connect to Kafka. Async. I'll be using try catch. If there is any error, we can write it here. I'm using try catch because this handler works for the endpoints. And here, await, producer, and connect. And let's say producer connected. Okay. As soon as we start our API, we are going to run this function and connect to Kafka. Let's open our terminal, start our application again. Actually, I can write here a watch flag. So if we make any changes, it's going to automatically restart our application. By the way, there is something wrong. Of course, it's going to be JS, not Kafka. We made the same mistake here. It's going to be Kafkajs. Okay. And as you can see, producer connected. So it works. And now the only thing we should do is send a message to payment success topic. So I'm going to come here and I will say await producer.send. And I'm going to write here my topic name, which is payment successful. And right after, I'm going to write my messages. We can send multiple messages, so I'm going to be using an array. And the value of this message will be, let's send this card and user ID. But before, we should stringify them and pass here the user ID and the card details. Remember, it includes all our products. These. Okay, I'm gonna save, and now we can consume that message in the analytic and the order services. Let's remember again, we are gonna consume this message here and here. Let's create. I will come back. Again, we are gonna connect to Kafka, but this time here is gonna be consumer. Let's open our analytic service. I can close this client, by the way. I will say import Kafkajs. Paste it here. Change the client ID. And here is gonna be consumer. And of course, you can create multiple consumers. So you can separate them by using a group ID. And it's going to be, again, analytic service. Okay. Let's create our run function. And call it here. And firstly, we are going to connect to our Kafka service. I'll say try catch. I'll just send the error And here I'll say await consumer.connect. And after the connection, we are going to subscribe to our topic. So I will say await consumer.subscribe. And we are going to pass here our topic. And it's going to be payment successful. And I'll say from beginning, and it's going to be true. This means if the connection is lost and get back to online again, it's still gonna fetch all the messages from Kafka. Okay. And finally, we are gonna listen to this topic, and for each message, we are gonna return maybe just console log. So I will say consumer.run each message async function. We can get the topic name, its partition number, and the message itself. Let's get the value. I'm gonna close this menu and console, by the way, so we can see better. I will say value, message.value, and to string. Remember, we are sending here a value, and inside this value, we have the user ID and cart. Let's take them. Const user ID and the cart. This time, we are going to transform our string to a JSON object. So I'm going to pass here our value. If you remember, in our products, we have the prices here. We can calculate the total number, and we can console log. So let's say const total number cart.reduce function. We are going to add each value just like that. And let's say console log analytic consumer. And let's say this user ID paid the total number. Okay, I'm gonna open my console. Let's create another tab here. Services, analytic service. I'll say not watch index.js. I hope everything is alright. I'm gonna enter. And as you can see, consumer has joined the group. And this is our topic name. Let's try. I'm gonna open my client application. Click here. It's successful. And as you can see, user 123 paid this number. Of course, I can write here to fixed. So we are gonna see only two numbers after this dot. Let's try again. And it's here. By the way, when you restart your server, it can take a while, but once it's connected, it's gonna be instant answer. Just like that. Of course, we see here the instant answer because we don't have any payment implementation here. In the previous example, I just added here 3 seconds delay. So when you implement the payment, of course, it's gonna be slower, but of course, it's not gonna be 12 seconds anymore. It's gonna be just 3 seconds. Okay, this is how we are producing and consuming messages. If you want to, let's do the same thing for the other services. Let's remember again. We are also consuming here. And as soon as we consume that message, we are going to produce order successful. And we are going to consume that on this service and on this email service. Let's do that. I'm going to copy everything here. Open my order service and paste. It's going to be order service. But also we are gonna need the producer. So I will say producer Kafka.producer. We are gonna connect. And we are gonna subscribe to the payment successful topic again. But this time, after taking the message, we are gonna produce a new message. After getting the user ID and the cart, you can create the order. I'll just say to do. And after that, our database is gonna give us the order ID. For now, let's say dummy order ID. I'll just give some numbers. And using the producer, we are gonna send a new message. Remember how we are doing this: topic and the topic name, order successful, messages, and the value will be JSON.stringify, and we can pass here the user ID and the order ID, and it's gonna be dummy order ID. And we are gonna consume that in the email service. So again, we are gonna do exactly the same thing. I'll open my email service, paste my code, close my menu, and this time here is gonna be email service. Again, we are gonna be the producer and the consumer, and we are gonna subscribe to order successful topic. And when we receive the topic message, we are gonna get the user ID and the order ID. Here is gonna be the real world implementation. Let's say send email to the user. After that, it's gonna return us any email ID or any data you want. Let's add here some random numbers again and create a new message. And this time it's gonna be email successful. And we are gonna pass here user ID and email ID. Of course, we can write here a console log to see better. I'll say email consumer. Let's use here actually a backtick so we can use JavaScript. And I will say email sent to the user. Or say user ID and the user ID that we received. Let's write console log here also. After consuming and creating an order on the database, I'll say console log order consumer, order created for user ID, and again the user ID. Okay, so right now we can consume this message and this email message in the analytics service, because remember again, we are actually consuming all of these topics. But we are going to make a change here. So what I'm going to do is change here to topics. In this case, it's going to be an array. And inside this array, we can add different topic names. Order successful and email successful. And this time we can receive different topics. In this case, you can use a condition. For these kind of situations, I prefer using switch case blocks because we already know which topics we are going to receive. It's going to be only one of them. So I will say switch. Here is going to be the topic. If the value is payment successful, we are gonna return this. I will just cut this and paste it here. Let's close this just like that. And I'm going to create 2 more cases. Here is going to be order successful and email. In this case, we are going to get the order ID and user ID. Let's remember again. User ID, order ID. We don't need this. And I will say order created for user ID. And I'm going to use my user ID here. We can also add our order ID. And for email successful, let's remember we are sending user ID and let's say email ID. Let's get rid of this and change our text. Send to user ID. Okay, so let's open our console and create other services. Analytics service, I will get back. Order service. Node index.js. Oops. Okay, there is a warning. Connect is not defined. Of course, it's going to be producer and consumer. Let's fix here also. And let's try again. I will do the same thing for the others. Let's get back. Email service. Node index.js. By the way, as you realize, they are printing the previous messages because we are using here from beginning. So it's gonna read all the data. Okay, we don't need here. I can close. Okay, awesome. We have 4 items. Let's create one more. I'm gonna click, it's successful. And the 5th item. Order created, email sent. And here, since we have subscribed to 3 topics, it's gonna write user paid this number, then the other topics. It's that easy, guys. We are just creating the producer and connecting, creating the consumer. And if we want to send a message, we are using the producer. If we want to receive the message, we are using the consumer. Okay, awesome. But there is a problem here. If something happens to our broker here, all connection is gone. So what we should do is, instead of creating only one broker, we should create multiple. So even if one of our broker is down, others will be connected and we are gonna keep seeing our messages here. So we need to make some changes in the Docker container. I'm gonna actually close everything, open my Docker compose, and let me show you how to create a Docker cluster, and after I'm gonna explain everything here. Okay, right now instead of using a single Kafka server and single topic partitions, we'll create a Kafka cluster. Let's say Kafka cluster. And firstly, I'll add more partitions for each topic. And now let's create 2 more Kafka. In this case, we can change the container names. Let's say Kafka 1, Kafka 2, and 3. And remember, each Kafka server is a broker. A broker can store, send, and receive messages. They receive messages from producers and send them to consumers. But how we are gonna know that which broker and which topic partitions we should use to manage messages? Before, we were using a coordination service called Zookeeper, but it was the most hated part of Kafka. It was slow and added extra complexity to managing the cluster, but Kafka released a new mode called Kraft, and we don't need to use Zookeeper anymore. It manages all the metadata and cluster coordination internally. Now, to make that work, we need something called a controller. It decides which broker becomes the leader for each partition. When a broker is down, the controller picks the new leader from the healthy brokers. You can create independent controllers, but also you can use your brokers as both brokers and controllers at the same time. In this case, they will also be the controllers. And when we run our Kafka cluster, the controllers select an active controller, in other words, the leader. And it works like an election system. For example, it says, I should be the leader. The second says, the third one should be the leader. And when this last one says, the first one should be the leader, it becomes the leader because it gets the majority of the votes. And the others become the followers. The leader writes all the metadata to an internal log, and the followers replicate the log entries. So even if one of our broker is down, we won't lose any data. And if the leader is down, the election starts again and one of them becomes the new leader. But since there is an election system, you cannot lose more than half of your brokers. If it's gone, our system will also be gone because there should be at least 2 candidates. That's why it's important to use odd number of brokers, like 3, 5, 7. Okay, now you know how a Kafka cluster works, so let's go back to the compose file and see the configuration. Let me explain every variable here. You already know the node ID. This is basically our broker's ID, and it must be unique for each broker. Remember, each broker is a broker and a controller at the same time. And this defines how Kafka listens for incoming connections. Plain text for the broker communication, controller for the controller communication, and since we are using an external application to connect to Kafka, we need to add this external listener. Remember, in our applications, we are listening this port number. So this is the same number. And these are the addresses advertised to clients and the other brokers. So when they communicate with each other, they will use this address, and when our external application communicates with Kafka, it uses this address. And here we are defining each voters. Remember, there is an election system and we need to define the voters. In our example, we just have one broker and one controller, but when we create more, we have to add them here. What about this one? Basically, for each listener, we need to define the security protocol. And plain text means the communication is not encrypted. This is how we can directly connect to Kafka server without using any username or password. But in the production, this connection should be SSL connection, and we should define a username and password. For the controller communication, we will be using this name that we defined here. For the broker listener name, we are going to be using plain text here. And now I can create 2 more Kafka services. I'm just going to copy this, paste 2 times. In this case, I'm going to change the name of the Kafka containers. This is going to be, let's say, Kafka broker 1. Here is going to be the same. I'm going to enable the Kraft mode. By the way, instead of using an equal sign, let's use colon so we can see better. Just like that. I will do the same thing for the others. So let's delete them and copy and paste again. But before, I'm going to add here one more thing, and it's going to be the cluster ID. Kafka Kraft cluster ID. Basically, when you create a Kafka cluster, you need to define a cluster ID, and this ID should be the same for all brokers. This is how they know that they are part of the same cluster. If you want to generate a code, you can open your console. Let's choose Kafka. And it's basically going to generate a random ID. Of course, you can add any ID you want, but this is the best way to create. As you can see, there is a random ID here. Let's copy, close the terminal, and paste here. Right now, I can do the same thing for the others. I'm just going to duplicate this. This is going to be broker 2. ID will be 2. And I'm going to change this external port number so we can listen this second broker in our applications. Let's do the same thing for this third one. Node ID will be 3. Here is going to be 6. Just like that. And now we can add here our controller's port numbers. Remember, the first one is Kafka broker 1, and the controller runs on this port number. So let's say Kafka broker 1 and the controller port number, and I'm going to create 2 more. I'll say comma. The second one will be broker 2. Again, the same number because the controller address is exactly the same port. And the last one. Just like that. Let's add this for each broker. And here, we can change this. Depends on, it's going to be, what was the name? Kafka broker 1. Two and 3. Okay, let's see. I'm going to open my terminal again. If you didn't stop your Docker services and microservices, just terminate them and delete your containers. And let's create our cluster. I'll say docker, compose, and up. I don't want to see the logs, so I will say -d. By the way, there is something wrong. There is a problem because since we are using map, we should delete this list sign because we are using colon here. If you are using a list format, you can use the key and the value. But if you are using the map format, you don't need this list. Let's delete them. Just like that. And this one. Just like that. By the way, I didn't change here. It's going to be broker 3. And 1. Okay, let me check one more time. Broker 1. It's here. Waters. Cluster IDs are the same. This port number. And by the way, for the UI, we should also change the Bootstrap servers. We are going to add all our brokers. Kafka broker 1, broker 2, and 3. And it's going to run on this port number. Okay, let's try again. Docker compose up. They are here. Let's check. It's initializing, and at the end, we are going to see that it's successful. As you can see, server started. Let's see the others. Okay. And the last one. Okay, they work. Let's see our UI. I'm gonna refresh the page. As you can see, we have one online cluster, and inside this cluster, we have 3 brokers. And as you realize, the first one is the leader, which is active controller. Right now we can add our topics, but this time we are gonna add multiple partitions. Payment successful. Number of partitions, let's say 3 partitions. And this defines how many copies of each partitions are maintained across different brokers. Let's say 3. I will create. And as you can see, we have many replicas. And now our system is fault tolerant. For each replica, we have different leaders. And let's do the same thing for the others. And after, we are gonna test our applications. This is gonna be order. And one more, and it's gonna be email. Okay, let's write the new brokers to our microservices. I will open my menu. And I'm gonna add here the second and the third one. 1995 and 96. Let's copy this and paste for the email service. Order service. And the payment service. Okay, let's start our applications again. This is the payment service, producer connected. I will close this menu and let's start them. Okay, they are connected. Let's try. I'm gonna click. And they are here. It works. So this is how you can create fault-tolerant systems. You can deploy different Kafka brokers on different servers. So even if one server goes down, the others will keep running and the system will be alive. Okay guys, this was a simple example of how to use Kafka and microservices. When I searched on YouTube, I mostly found basic slideshow explanations of how Kafka works. So I wanted to show you how it actually works with real code. I hope you liked it. If you want me to create more Kafka and microservices projects, let me know in the comments. If you learned something new today, please like the video. And don't forget to follow Lama Dev's social media accounts. I hope I'll see you in the next tutorial. Goodbye.